Hey everyone, welcome to my YouTube channel. So today in this video we are going to see binary search in 2D arrays. Okay, this is also a most important video because companies will generally ask you to find an element or find the index of an element in 2D arrays. Okay, so let's see binary search in 2D arrays. Fine. Okay, binary search in 2D arrays. Fine. So the first type of problem you'll see generally FAANG company will ask you or other MNC company will ask you is row column matrix. Okay, so what is row column matrix? Okay, 0 1 2 3 0 1 2 3 10 20 30 40 15 25 35 45 22 32. Okay, 32 43 43 and 53. Fine. 73 89 98 99. Okay, now see carefully. See, observe zeroth row, which is 10 20 30 and 40. Zeroth row elements are placed in increasing order, that means sorted. Okay, observe zeroth column, that means 10 15 22 and 73. It is 73. Okay, this is zeroth column, this is, and this is zeroth row. Fine. So zeroth column elements are also placed in increasing order, that means sorted. So what is row column matrix? See, there are two categories. One is row matrix and other is column matrix. Row matrix means, okay, so row matrix means the elements in a row are placed in a sorted manner. Okay, column means same, the elements in column are placed in sorted. Row column matrix means the elements are placed in a sorted manner. Okay, in both row and column. You can take any row or any column. See, just take for example second row 0 1 2, third row whose index is second. You can say 22 32 43 and 53. 53. Okay, just take the last column 40 45 53 99. So row column matrix means the elements are placed in a sorted manner in row and column. Okay, now how to solve it? Your task, the next thing is, because actually we want to find out the index of an element or an element using binary search in a matrix or a 2D array. So how to do it? So next thing is your task. Your task is to get me the index of element 43. Get me the index. This is my target index. Target index. Okay, so now how you will calculate it? There is a step-by-step procedure. Okay, there is a step-by-step procedure. So let's see it. Target is 43. Okay. Fine. So this is our matrix. Now let me put it in the center. Now, the very first thing, the very first thought comes in your mind, that how to calculate the index of element 43. How to calculate index of element 43 is just apply linear search. The very first thing comes in your mind is the just apply linear search, because we have already studied linear search. We've already studied 2D arrays. Okay, we've already studied how to use 2D arrays, how to search element in 2D arrays, and how to put the conditions. We've already studied. If you haven't watched, then please watch the linear search video. Okay, we've already studied. Then so how to use it? Use for loop. It will traverse through row wise. Inside it, use another for loop. It will traverse through column wise. Then put the if condition and check if my target is equal to matrix of row and column. If yes, then return the answer. Yes, but it takes O of n square time complexity. What is O of n square time complexity? What is O? What is big O? Okay, this is known as, we used to call it as big O. Okay, what is big omega, big theta? We will study in time and space complexity later in this DSA series. Okay, because I'm gonna post 2 or 3 hour complete dedicated video of time and space complexity, so don't worry about it. Okay, just to understand, let me clear you. What is O of n square? Suppose, yeah, suppose rows, size of row size is equals n. Okay, first you get to know, if you haven't watched, then please watch the 2D arrays lecture. Okay, in the linear search last part, I from the detailed, I have taught you what is 2D arrays. Okay, so this for loop will traverse row wise, and this for loop will check the column. This for loop travels row wise, and this for loop check the columns. Row and then column, row and then column. Once it reach to this column and check the column, it return the index. Okay, now the second thing is why we should not use this, because O of n square. Now what is O of n square? See, suppose the row size, in the worst case, suppose the size of matrix is n. Okay, and the columns are also n. So the outer for loop traverse n times. Okay, suppose it traverses n time. 1, 2, 3, 4, 5, 6, 7, n. Okay, and in the worst case, suppose the columns are also n. N is any number: 1, 2, 3, 4, 5, 600, 200, 1 million, 2 million, 3 million, 1 billion. Okay, 1 billion, 3 billion, any. N is any number. So suppose the rows are n and columns are n. The outer for loop traverses n times, and inner for loop traverses n times. N into n equals n square. That means time complexity is O of n square. So what it means? It means if n is equals 100, then it takes max to max 10,000 iterations to get me the answer, to get me the index of my target element, and it's a huge time. That is why we will avoid linear search, because you need to find the answer in O of n time complexity. Okay, I have given you this, that you need to find the task, you need to get me the index of element 43 plus time complexity should be O of n, not more than that, Okay, that means if my array size is 100, then it should take at the worst case 100 iterations. Okay, but in this case, in nested for loops, in this case, in linear search, it is taking O of n square. We have seen how O of n square. So how to do it? Let's see how to do it. Okay, so let's see. My task is index of element 43 in time complexity O of n. Okay, got it. Now see carefully. See carefully. This is lower bound LB. This is upper bound UB. Okay, fine. This is lower bound, which means 0 0. Okay, and upper bound is 0 comma 3. Okay, 0 throw and last column. Okay, the index is 3 0 1 2 3. Okay, fine. In the binary search, we generally follow 3 cases. The first case, if target equals mid element. Okay, suppose in 1D array, okay, this is 1D array and this is the 1D array. Okay, and we apply binary search. Fine, we apply binary search. Then we check 3 cases. If my target equals mid element, first we'll calculate the mid element. Okay, and then we'll check if my target is equals mid, if my target is greater than mid, okay, or if my target is less than mid. 3 cases. Okay, here also we'll apply the 3 cases. This is for 1D array. Okay, in this case, steps. The first step is you can check also from lower bound, but I will prefer, or I'll check from upper bound also. Upper bound. Okay. Check if upper bound equals target or equals, if upper bound is greater than target, less than target, or equals target. Check this condition. If upper bound is less than, greater than, or equals to, see what is upper bound, 0 comma 3, that means 40, 0 comma 3. What is target? 43. Okay, 43 is the target. Fine. Okay, now check it. Is 40 is greater, less, or equals? 40 is less than. 40 is less than. That means we can eliminate. It is the most important point. I will write it in green color. Yellow? No, not yellow. Green is best. Eliminate row. Or I can say row plus plus or lower bound plus plus. Now, this is the conclusion 1. Conclusion 1. How? I'll show you. 40 is less than 43. That means upper bound. Our upper bound is less than target element. That means all the element before it. We already know that upper bound is the last element, last column element. That means all the elements before it are less than. Why? Because it is a row column matrix. What is row column matrix? Row column matrix is the matrix where the elements are arranged in ascending order or descending order. This is the elements are arranged in ascending order. That means if 40 is less than 43, that means all the elements before it also less than. Why? Because it is ascending order. increasing order. If the last element only less than target, then it is clear then all the elements before it is less than target. If all the elements are less than target, then what is the point? What is the point to check in that? Eliminate it. Eliminate means move this lower bound to here. Okay, and now we have eliminated this row. Okay, so now the new upper bound is this and new lower bound is this. Getting my point? Fine. Now again check, repeat the steps. The second is repeat the steps. The second is repeat the step. That means again check. Is upper bound greater, less, or equals to target? What is upper bound now? 45. Upper bound is shifted here. No, this row is eliminated. 45 and target is 43. Now 45 is greater. 45 is greater. That means eliminate the column. Okay. That means eliminate the column. This is conclusion 2. How? See here, if this is the element which is greater than target, then all the elements below it definitely greater, because it is column matrix also. With row matrix it is column matrix, row column matrix. See 40, 45, 53, 99. Increasing 30, 35, 43, 98. Increasing 20, 25, 32, 89. Increasing 10, 15, 22, 73. Increasing. So if this is greater, then all the elements are greater. No point of checking in this. Eliminate this also. Upper bound shifted here because it is eliminated. Upper bound shifted here. Again check. Okay, so let's in the next page. Again check. Again check. If upper bound is greater, smaller, or equals my target. Target is 43. Okay. So yeah. Now lower bound is this, upper bound is this. Upper bound means 35. 35, target is 43. 35 is less than. That means if upper bound is less than, then eliminate row. Lower bound comes here, upper bounds here. Again check. Upper bound greater, less than, or equals. What is upper bound? Upper bound is 43. Target is 43. Equals. That is the answer. Return 2, which is the indices in 1D array. How to return? New int 2, 2. Simple. We got the answer. And this is the most important steps. Lower and upper bound steps. To find element in matrix or 2D array uh, when given the matrix as row column matrix. Okay, how you are feeling? Nice, right? Okay, so this is what the first type of problem you will get. Now I want you to write the code, please. I want you to write the code. Okay, I will write the code. In the next lecture we are going to unleash the power of building confidence intuition, and that will be the best video ever of binary search, because in that video we will prove that there is no such hard problems. There is no hard problems. Google, Microsoft, Facebook, we will do all the problems which are asked in these companies, and in an easy way. I assure you, you will at the end of video you will write the comment like it is a super easy problem that Google has asked, Microsoft has asked. Okay, so in the next video, the very first problem I'll be taking to get the index of the element in matrix. But before it, I want you to try the code. I want you to try the code. I'll be publishing the solution, okay, in the questions in the problems video. But I want you to try the code before it, because it's super easy. We have already, if you have seen my binary search video, then easily you can just try, then you can easily make it. See, there are three conditions inside the while loop. There are three conditions, and just check that is it upper bound is equals to target, equals to target, equals to target, less than, then just put, change the lower bound upper bound. If get greater than, then just eliminate the row. Okay, and then check till it is equals to target. Okay, get my point? Just try it. Okay, I want you to try it. Okay, the second is the first is row column matrix. The second is sorted matrix. Okay, sorted matrix. The time complexity of this first is O of n. Okay, fine, and the space complexity is, and the space complexity is O of 1, because we are not taking any auxiliary space, any extra space. Okay, and why time complexity is O of n? Because we are checking the element once, just once. Okay, that's why. Fine. So sorted matrix. Okay, fine. What is sorted matrix? Okay. One, two, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Sorted matrix. Okay, suppose your target element is 2. Now listen carefully, because the algorithm to solve sorted matrix, the algorithm to find the index of element in sorted matrix, it's somewhat lengthy. Okay, simple but somewhat lengthy. Fine. Steps. The first step is find either mid column or mid row. 0, 1, 2, 3. 0, 1, 2, 3. Find either mid column or mid row. I generally go with column. Okay, you can also solve it with row. Okay, so how? Mid column, length minus 1 upon 2. What is the length? 4 minus 1 upon 2. That means 3 upon 2. That means 1. Okay, so the mid column is 1. This is my middle column. Okay, so this is my mid column. Okay, this is my mid column. This is the first step. Fine. The second step is find the mid of that column. Find the mid of that column or row. If suppose you have if suppose you are going with finding the mid row, then find the mid of that row. Suppose, okay, I have already, in the first step I am going with mid column. Okay, so I am finding the mid of that column. Okay, so what it is, see, we have already calculated that our mid column is this first column. Okay, now I need to find the mid of this column. So how to find it? This is my column 2, 6, 10, 14. 2, 6, 10, 14. How to find the mid? Same, length minus 1 upon 2. Length is 4. 4 minus 1 upon 2, that is 3 upon 2, which is 1.5 in the integer 1. Okay, that means this is my mid. This is my mid element. Now the most important step is third step. So let me take this complete to the new page. Fine, okay, put it into the center. It looks good. Okay, now the third step is our mid element equals 6. Okay, 6 is our mid element we found in the second step. Okay, check if the target is greater than, equals, less than, or equals my mid. What is the target? Target is 2. Right? We want to find the index of 2, and mid is 6. If it is greater, small, or equals, it is less than. Our target is less than 2. Eliminate last 2 rows. Conclusion 1. See carefully. Let me explain this step. Okay, so zoom out. Fine, okay. So if my target element is less than mid, then eliminate last 2 rows. See, my target element is 2. Okay, and it is less than 6. What is the point of checking in these rows? What is the point? We have found out first conclusion that our target element, which is 2, is less than mid element. 2 is less than mid element. Okay, and all the elements after mid is greater. These elements. These elements are greater than mid element because it is sorted matrix. Okay, so what is the point to check in this? In binary search, in 1D array, we usually do this only, right? This was our array. Okay, and there are some elements. Okay, it is a midpoint. Suppose my target element is this. Okay, and it is a increasing order, sorted. What is the point to check in this? because if my target is less than mid element, okay, that means my target should be less than after all the elements, and it is an increasing order. Then what is the point of checking this? So the same way, what is the point to check in these rows, these two rows, if my target is less than my mid, because it is a sorted array. Okay, so we will eliminate last two rows if my target element will be 11. If my target element will be 11, okay, so in this case target element is greater than mid. Okay, if my target element will be 11, suppose if my target element will be 11, okay, and my mid element is 6, in this case target element is greater than, if my target element is greater than, okay, mid, if my target element is greater than mid, then what is the point to check in these upper two rows? What is the point to check in these rows? Okay, if my target element, this 11, is greater than 6, then definitely no need to check in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. I definitely check in last two rows only. I definitely check last two rows and then get me the index, try to find the index of my target element. Get my point? So we can eliminate, in that case, we can eliminate upper two. If my target element will be 13, upper two. If my target element will be 5, last two. If my target element will be 8, last two. Get my point? So this is the third step. If you are still in doubt, please pause this video, okay, and then rewatch. Okay, please rewatch it. Okay, just change the speed and then rewatch. Fine. I don't think you'll have a doubt. Okay. Now this is the third step. So what will be our newly updated array? What will be our newly updated matrix? Is step 4. Our newly updated matrix is 1, 2, 3, 4, 5, 6, 7, 8. This is our target. This is our mid. Okay, 0, 1, 0, 1, 2, 3. Okay. Now the step 4 is, see, this is only right. We have already eliminated last two because target is 2. That means 2 is less than 6. So there is no point of checking last two rows. We have eliminated it. Okay. Then the left is only first two. Okay. And this is our mid column. Okay, this is our mid column. Now check that in mid column. Check in mid column. Okay, that any of the elements equals target or not. Check that in the mid column. Check. Okay, check that if it is equals my target. If it is equals my target. It is equals my target. No, it is equals my target. Okay, so return in this case. But wait. In this case, return index of 2. Okay, but if suppose target element will be 3. Suppose target element will be 3. Okay, then first you need to check that in our mid column, any of the column is our target. Okay, in this case, if target is 3, then 6 is target, no. 2 is target, no. Now step 5, last step is step 5. Convention. Step 5, apply binary search in other 1D arrays. It means if suppose my target element is not found in mid column, then 1, 2, 3, 4. Apply binary search and then search it. How to apply? See here. In the 5th step, we'll create a method. Name as binary search. Okay, and the input is first this matrix. Okay, row and column start. Okay, column end. Why? Okay, let's see why. Because how black suits. Okay, because you can see, apply binary search, just pass the matrix. Okay, you need to pass the matrix, definitely. Fine, just pass the matrix. Okay, now you will be asking, okay, we will pass the matrix. Okay, then how we will apply binary search in just this 1D array, this 1D array, this 1D on this 1D? That's why we are just passing row, column start, column end. Row, suppose target element is 3, just pass the row as, if target is 3, pass the row as 0. Okay, column start as 2, column end as 3, column start as 2, column end as 3. If target is 5, this is a use case. Okay, if target is 5, then pass the row as 1, column start as 0, column end as 0. If the target is 8, pass the row as 1, column start as 2, column end as 3. Simple. Okay, and why I'm telling you this? Because I want you to write a code for this problem also. Please. In the next video, I'm going to publish all the solution. Okay, in detail, using debugging mode, everything. Okay, but I want you to try the code. Try to code this. See, the steps are clear. The first step, find the mid column or row. Okay, you have found the mid column. This is the mid column. Next is find the mid of you have found the mid column. Okay, find the mid of that column or row. This is my mid column and the mid of that is 6. Okay, the next step is the mid is 6. Now check that the found mid is greater, less, or equals to target. If it equals to target, you are lucky, very lucky. Return the that row column. That means indices. Okay, if you are not lucky, okay, then check if target in our case it is 2, is greater, less, or equals to mid. If the target is greater, Okay, then eliminate upper two rows. If the less, then eliminate lower two rows. Just first see carefully, okay, not do this blindly. Okay, see here, if the target is this in our case, if target that is 2, which is less than, so there is no point to check in that. That's why we have eliminated last two rows. If the target will be 11 or 9 or 10 or 11 or 12, 13, 14, 15, 16, then there is no point to check in these rows. That's why we will eliminate upper two. Okay, let me write here. Eliminate upper two rows. Conclusion 2. Okay, now the next step is we will left with the remaining array, the remaining matrix, the remaining eliminated matrix. Okay, check in that mid column. First we have calculated the mid column. Okay, check in the mid column that any of the element of that column equals target or not. If it equals, you are lucky. If not, you are not lucky. Okay, so if it equals, then return the R and C. Okay, row and column. If not, then just divide, use these cases. Suppose if the target, if not, then if the target is 3, 4, 7, 8, 5, 1, definitely if the target is 3, that means just create a method, binary search, and pass matrix row column start column end. Okay, matrix row int. If target is 3, suppose if the target is 3, row is 0, 0th row, fine. Column is 2, column start, column end is 3. If the target is 5, pass the row is 1 because in first row. Okay, column start is 0 and column end is 0 because there is only 1. Okay, these are the 4 different 1D arrays. 1, 2, 3, 4. 1, 2, 3, 4. Okay. If suppose target is 8, then row, first row, and this 2 column start column end. Okay, so these are the steps. Okay, and this is the main method. Fine, you'll create. I have shown you because I want you to just write code. I have already shown that what you need to do, what are the steps, and at the end what you need to do is, okay, just do it, and I very well know that, okay, you will definitely write the code. If not, then okay, I'll be publishing the solution. Okay, so this is what all about 2D arrays. Search the element in 2D arrays. Okay, and it is also a target topic of FAANG interviewers. The next video will be the life-changing video because in that video we will be solving Amazon, Google, Microsoft problems, hard problems that makes easy problem. Hard problems that is super easy. Okay, that is actually hard problems. You can see lead code hard problems. Okay, that is asked in Facebook problems are really hard. Okay, so in the next video we will be solving Amazon, Google, Facebook, Microsoft hard problems. Okay, which is not actually hard. Okay, and I guarantee, I assure you that you will be mesmerized. Okay, and it's around 4 to 5 hour video. Okay, so I divided that, and it's really mesmerized video. It's really super great video because in the next video only you will build the intuition problems. Okay, these are the problems. I need to apply binary search in this way. I need to apply binary search in that way. Get my point? And the hard problems after watching that video, you will be just like, okay, this is the hard problem. It doesn't look like it. I can solve any problem of binary search. Fine. So this is all about the video, and let's meet in the next video of the problems video. Okay, and that is the Superman video. Okay, I'll just call it as a Superman video. Fine. So if you like the video, then please share, subscribe. Okay, comment down. Comment is necessary. Comment down, and yeah, subscribe, and thank you.